This is Vassili Georgakopoulos, and I'm doing my presentation and project on abrasion-resistant and flexible silica infused nylon 6. So to get started, nylon 6 is a very common material used in the fishing industry because it provides high tensile modulus, it's greatly flexible, and it has a high abrasion resistance. Silica particles, and in particular nanotube structures. These are silica molecule chains that significantly enhance the strength and abrasion resistance of the polymer. On the left is a standard nylon 6. This is the outer surface of the filament. It's very rough and has a low density. On the right is nylon with silica nanotubes. As you can see, the surface is much smoother and the material is much denser. This allows for the filament to have greater abrasion resistance and a higher tensile strength. A comparison against nylon 6 and the silica infused nylon 6. The silica infused is twice as strong and is 60% less prone to straining. Flexibility-wise, the bonding chains that the silica provide to the nanotube structures increase the strength but also significantly increase flexibility. Abrasion resistance was won by the silica-infused nylon. The polymer's shore hardness was much greater. In this graph, we can see a strain is put on the standard nylon and it begins to stretch and then breaks just over 200 megapascals. On the other hand, we have the infused silica, which as a strain is induced, the filament resists stretching and breaks close to 400 megapascals. This difference is quite significant. Some disadvantages of standard monofilament is that it stretches quite easily and after a few uses it needs to be discarded. There is also a very low tolerance for abrasion resistance from fish's mouths and in structural environments such as reefs, and the elasticity is high, causing issues when fishing. This table shows the different combinations of silica and calcium carbonate with the nylon 6 polymer. The maximum tensile was achieved at 0.02% silicone and 0.007% calcium carbonate. Some quick facts about the fishing industry. It's a $90 billion market, 800 million goes to fishing line every year, and from 2009 to 2012, consumer spending for fishing line increased by 45.3%. This is a global map of fishing. As you can see, it's a common practice, business, and lifestyle all around the world, and it goes to show you how greatly we rely on fishing. 260 million people are employed by the fishing industry. 0.01 to 0.02% of the filament is comprised of silica particles. The silica particles are ultra-fine ground to the microscopic level. These silica particles will create the nanotube structures that significantly enhance the tensile strength of the filament. Finally, calcium carbonate makes up 0.007% of the polymer and is used for stiffness and to increase the shore hardness of the filament. For our method of production to create the resin, we sourced and designed our resin through Nylon Global Polymer Solutions, and the resin came in small pellets. Next was the extrusion process, which was melting down the resin at 260 degrees Celsius, and the filament is driven out through a nozzle that connects two winding spools. After the extrusion process is the drawing process, which is where the tensile strength and hardness are developed. This process of winding the line through various spools to drive down the diameter builds the filament's strength. The silica is not only an additive for the polymer, but it significantly increases the strength from the helical bonds known as nanotube structures. These bonds form all over the filament and work together with the polymer and calcium carbonate to enhance the performance of the filament. The science behind the silica nanoparticles is that these helical structures make the outside surface smoother and denser, which allow the filament to resist abrasion and wear and tear. We tested a standard nylon monofilament, the Silica infused nylon, and fluorocarbon. They were tied to equal weights and were cycled back and forth on sandpaper until each achieved failure. The standard monofilament withstood an average of 39.6 cycles. Fluorocarbon came with the lowest amount of cycles resisted. The silicone-infused nylon came out with the highest amount of cycles, resisting an average of 64.3 cycles. The vision started when I realized how much of a problem fishing lines have lacking abrasion resistance. I wanted to create a fishing line that could withstand some of the toughest fishing conditions ever. I used FAU wave research papers, companies, and experts in the field to develop an abrasion-resistant line that would outperform any other filament on the market. Business-wise, the pricing of the silica-infused filament is identical to standard monofilaments, close to 3 cents per yard. I have already established relationships with the Nylon company, a reputable resin manufacturer. I have found a company located in Melbourne, Florida, that can produce the fishing line using the resin. For sales, starting in local fishing shops is where I would begin and eventually move into bigger stores. After the business is up and running, investors would be an option to scale the company to greater size. And finally, the filament could serve an additional purpose in medical fields, for reconstructive surgeries, catheters, and other devices. The nanotube structure provided from the silica particles create a new dynamic fishing line when combined with nylon 6. I plan on launching the company in a few months and hope to begin sales as soon as possible. Thank you all for your time.